Hi, my name is Jörn Zaefferer, and I'd like to talk to you about making websites accessible. Since accessible is kind of this odd word that it's not always clear what it actually means, this talk, while this was too long for a title, I actually want to talk about making websites usable for people who can't see well. Let me illustrate what I mean by that. So this morning I was looking out of the window of my hotel room. It was a tiny window where I could see the old town of Gdansk. And this is basically what I saw after putting my glasses on. So without them, it might have looked like this. So like, taking them off, I don't see that well. My eyes aren't that great. But in my case, glasses help. In other cases, maybe you see something like this, and glasses don't really help anymore. So it still might be worse, though. Something like this, where it's basically just like a blob of light. You can still recognize there's something, but obviously you can't really use your eyes in a useful way. And in most countries, it's probably considered legally blind. There's still the complete blindness where you can't see anything at all, like just your eyes don't do anything. But even if it's just this, using a computer, for example, where you have to use a screen, is pretty useless. So the odds are good that you don't actually know someone personally who's blind or has really bad vision. I'm sure you know lots of people with glasses, but the relative numbers of people with blindness or impaired vision aren't that big. But the absolute numbers actually aren't. If you consider how many people there are worldwide with impaired vision, taken together, like impaired vision and full blindness, there are 300 million people worldwide. That's the entire population of the United States. And for these people, certain technology can make a big difference in their life. For example, these are two screenshots from an iPhone app called Color Identifier. It uses the iPhone's camera, and the idea is you start the app, you take your iPhone, you point it at something, and it'll read out the color it can see at the center of the camera or center of the screen. And it'll just do that every 3 seconds by default. So in the two screenshots here, on the left, it would read out burnt umber, and the right would say very pale blue. So someone who can't see or can't see in colors, for example, people with color blindness, they can actually use this to see colors for themselves. The blind blogger Austin Zaefferer wrote about his experience using this application. And he wrote, "I went outside. I looked at the sky. I heard colors such as horizon, outer space, and many shades of blue and gray. I spent 10 minutes looking at my pumpkin plants with the leaves of green and lemon ginger." The full blog entry is, I think, even more inspiring. Austin is blind since birth, so for him this was the first time that he could see colors by himself. He didn't need someone to tell him what he's looking at. There are many more examples of technology that's specifically designed for people with disabilities. But what could be considered the greatest invention of our time is actually severely lacking. The internet is mostly inaccessible. Or in other words, it's mostly not usable for people with vision impairments. Let me illustrate what that means and how people will still try to use it. This here is comparable to something called a screen reader. This here is actually a very special purpose device. It's just designed to tell you how to drive from point A to point B. And all of these devices also have a voice component. Oh, interesting. Sorry. Well, you should have screamed a little earlier. So let me go. So I think you've saw. Okay, this is a map of the United States. I've talked about that. It's not that important. This is the color they define. Now you can actually see something. So the burnt umber is on the left and the very pale blue on the right. I read out the quote, so that's okay. This is just more text. So back here. So in this case, it's like a TomTom device, but it can be any GPS device. You can even just use your phone. These all have GPS sensors by now. But they all have in common, they have a voice that tells you, turn left, in 300 meters, slide right. And imagine that you have used this device and there's no screen, you only have the voice. That's basically what a screen reader is, except that it runs on a computer, laptop or desktop, or even on phones. And it's not a special purpose setup, just like the GPS that only does driving instructions, but it's more general purpose so that it can work with any software that you're using, including web browsers. So screen readers are basically the way that people who can't see can still use a computer, because they can use it for the to hear what the computer is otherwise displaying. And to illustrate that, or rather to whatever the word for making audio. Anyway, I'd like you to listen to this recording. It's me trying to browse a website with a screen reader. And I'd like you to try to figure out what is going on. And it's actually not easy to understand, because it's an example of a website that does not work well with screen readers.
Each page has 17 links, 4 auto web spots, 2 form controls. Open web item rotor, headers 0 items, links 17 items, auto web spots 4 items. Amazon edit text blank.
So that might have been a little confusing, especially if you've never heard a screen reader doing something like this before. Let's check that out again. This time I'll also show you the visuals, what was displayed on the screen while doing that recording.
Each page has 17 links, 4 auto web spots, 2 form controls. Open web item rotor, headers 0 items, links 17 items, auto web spots 4 items. Amazon edit text blank.
So among other things, it said no headers when opening this web item rotor. Headers are actually pretty useful for screen reader users for navigation. Also said edit text when moving focus to the search input there. Now we can actually see that it is a search field, but the screen reader doesn't know that, and all you can tell us it's edit text, which is the default description of any text input. And the sad thing here is that this site is actually, was originally designed to be used with screen readers. The only way that I found that in the first place was going to Amazon with a screen reader running, and it read out some text, go to amazon.com/access to have this on purpose designed site. And like, this is pretty bad. A lot of other sites are even worse. Like, they're broken, like this, or like this, or this. And I think we can do better than that. We can find these issues without a lot of effort. We can fix them. And I want to tell you how to do that, but before we get to that, I want to make it clear that this is actually important. That since you're here and listening, but there are so many other people who aren't, it's, I think now, basically your job to convince others that making websites accessible or just usable is important. And I think it's comparable to, say, user experience, or maybe even more so to security. It's not the most important thing. Like, your business doesn't depend on making your site accessible, I'm sure of that. But just like with this security, you don't want at some point in time your entire user database to leak to the public. Like, think of Sony and the PlayStation network. Like, you don't want that to happen. So you should actually spend some money on security, even though it's not the most important thing. And accessibility is similar. You should spend in the end, some money on it. For example, because you don't want at some point in time for a customer to call you and complain that your online banking site is not usable for him at all, because he happens to be using a screen reader and your site doesn't work with that. So how to actually convince your boss or your coworkers or clients or people working for you, or maybe just yourself, varies. I have a few ideas for you for convincing your boss. To start with, making websites accessible can actually boost the user experience. Designing with accessibility in mind from the start requires you to pay more attention to structure and content, and you still can make anything look good with applying CSS later on. But in the end, you'll then have a site that looks good and works better for everyone, instead of just a fancy looking site that's broken for a lot of people. by making websites usable with just the keyboard, like without the mouse, you can also support power users. Depending on what you're building, this might be interesting where people spend all day with your site and enabling them to use the keyboard, like maybe they use like Vim or Emacs where they also don't touch the mouse, and being able to apply that same thing to your site could make a big difference. Could also basically replace any effort for specific search engine optimization. If it's just specific for search engines, it's probably not great. There's a lot of FUD and dogma and stuff around there. On the other hand, if you actually start with meaningful semantic markup, it'll be useful for screen reader users and still be pretty useful for search engines. Again, good content and structure is really useful there. There might even be direct commercial benefits. Imagine that a lot of, say, e-commerce sites aren't accessible, so people who actually want to shop online, and if you can't leave your home, that's a pretty useful thing, that being able to shop online is useful. So if you're building the only like accessible e-commerce site, your competition doesn't have that, might actually be a commercial difference. There are laws to consider, and often these apply specifically in working on government websites. I have a few examples here from the USA, Germany, Austria, and UK. I don't know if there are comparable laws in Poland yet. I'm not sure because too many, like the English, Polish Wikipedia, I can't read that. But it's likely that there will be laws in the future since Poland also signed the UN Convention on the Rights of Persons with Disabilities. And it was only ratified last year in September. So since legislation takes a while, it's probable that there's no new legislation based on that so far, but it's likely to come. So if you're working, say, for the Polish government or clients in other countries, it might actually be a legal requirement. So to summarize, like which of these arguments actually work depends on your situation, but I think a good combination should work. And if they don't, there's another option, which I call ask for forgiveness, not permission. So spend some time with the things I will be recommending later on. Do some bit of testing, fix some obvious issues, and then demonstrate how easy it actually is, how little effort you need. And so instead of asking the first place to do that, and it's like, no, we don't care about that. There's no one who uses our site anyway. So you can just ask for forgiveness later on. And if you spend like an hour or a day on that instead of browsing Facebook, that's probably a good thing. So let's start at looking at actual testing. How can we figure out how to make our site accessible? And how do we find the issues that we might have? In some cases, it's just a matter of seeing, hey, we're using this, we shouldn't do that. For example, if you're using Flash, it's very unlikely that you're spending the effort to make Flash things accessible. It's possible, but difficult, so don't use Flash. It also doesn't work on most smartphones by now, so that's something that you shouldn't touch anyway. Something a little less obvious are captures, but they're basically the same thing. Captures are terrible, and not only if you can't see them. If you can't see them, usually the argument is, sure, but we've got the audio alternative. But these are actually just as bad, or maybe even worse. This is a recording of an audio capture from Google. I actually tried to solve it multiple times and failed, and I'll play it back so that you can believe me why I failed at that. It's not that I can't hear.
Please type every digit you hear. Spaces are not required.
2FM 53FM 73.
Yeah, so don't use captures, they suck. Let's see what else we can actually test where we need a little bit of effort, not just say this is terrible. I have 3 things to recommend. The W3C validator is a tool that you can use. We can do some keyboard testing, which is a little more manual, but really easy to do. And since in the end, if you actually want to support screen readers, we have to test them. Otherwise, we will have no idea what works and what doesn't. We need to do that as well. and start at the top. The W3C validator is pretty old school by now. It's really not about putting a W3C validator badge on your site, even though that used to be quite popular. But it's still useful to look for actual problems. For example, here's some test output from a site, whatever that was. And it has things like unclosed elements, duplicate IDs, and invalid nesting. This is from an actual production site. So these issues don't have a visual effect on that page, otherwise the developers would have noticed them, or their Q&A or whatever. But they can actually badly mess with screen readers. So whenever you have some issue that's not obvious from just visual inspection, the validator might help to find them. And a lot of the issues can mess with screen readers, so having some tool to tell you that what's wrong takes away a lot of other effort. But we also have to do some manual testing. And the next step I recommend is to do just keyboard testing. The idea here is, again, really simple. Just put away your mouse. Don't touch the touchpad either. Just take the keyboard, use the tab key to navigate inside the page, which will just move focus from one focusable element to the next, and then interact with any form controls. For example, if your text input type something, hit enter to submit a search field, or use keyboard, the cursor keys to select something from checkboxes, or rather radio buttons, or hit space to select a checkbox. Or if you have more like JavaScript components that actually support keyboard interaction, then try to use those as well. Let's look at an example of that. This video shows the Zaefferer site. It's an airline, you're probably familiar with that. They have giant advertisement over the top. And in this video or recording, I'm looking for a flight, and I'm only using the keyboard. There's a little bar at the bottom which mostly shows which button I'm pressing, and that's mostly the tab key, which is like basically this arrow with a pipe at the end. So I'll show you the first half. Okay, so I'll pause here real quick. So far what happened, I tapped to the search form to look for a flight, filled out the fields, used the autocomplete and the date picker, and then hit enter to submit the form, and it reloaded the page. So far that worked pretty well. So the search form itself doesn't seem to have any problems there. But in the next step, I'm actually looking for a flight, or trying to select a flight from their offers. So let's look at that. Again, the tab key. And as you can see, there's blue outline there, or was. So the issue here was until these two links at the bottom here, like starting from the search form, the submit button or something to these two links, there's either nothing focusable, or it doesn't have a visual outline when receiving focus. So this is broken. We can't use the keyboard since, while we can move the focus, we don't know where it is. So we basically have to, it's basically blind testing. We could just hit enter every once in a while and see if something happens. It's not useful. There are multiple issues here. One particular, to demonstrate the markup of this first button. So here I'm inspecting the button with the Chrome developer tools. And you can see that this button is actually an anchor, which is supposed to be used for links, but it doesn't have an href attribute. So it's not actually a link, and the browser doesn't consider this an interactive or focusable element. So probably when we were tabbing around, the focus never stopped on this button, so we can actually use that control at all. There's probably JavaScript attached to it, which does something when actually clicking. But since we can't move focus to it, we can't trigger a click event with the keyboard, which usually works just fine with any focusable elements. And this is an issue the screen reader user would also have to deal with. So with keyboard testing, we can find these even before ever running a screen reader. How can we fix this issue? I have this and two more slides with some somewhat broken markup and some suggestions on how to fix them. It's all pretty trivial. For example, with the anchor, if we actually have to use an anchor for some reason, otherwise our JavaScript breaks, then we should at least put the href attribute in there and just use a hash to basically as a placeholder. Or if our button is actually a span, then we can use the tab index attribute with a value of 0 to at least make it focusable. That's not great, but it's an improvement. Even better would be to, like down here, the last two, actually use a button element when we have something that's just a button and has no purpose otherwise. Or since selecting previous flight seems like something that could actually point to URL, we should actually use an anchor with a proper resource URL so that we can bookmark that and send it to someone else and so on. Here's another example. This is from that Amazon Access site. I didn't show the second page with the search results, but they had really shitty markup where they were using, instead of the header element, like an H2 here down here, they were using just a B to make it look bold. That's useless. It has no, it's just a visual thing, just useless for a screen reader user. They also used images without the alt attribute. This actually might be one of these accessibility recommendations that you heard before, where it says, whenever you have an image, you have to put an alt attribute in there. I want to improve on that recommendation a little. It doesn't really help to just say, for example, since this is like Samsung Galaxy something, putting the same text in the image alt attribute doesn't actually help since the text is already there. It should actually describe what the image is showing. And also, even if the image has no visual purpose, or actually, even if the image has no semantic or content purpose, it's just like a visual thing, like a divider line.gif or something, you still have to put an alt attribute in there and then give it an empty string. This actually tells the screen reader to ignore this image, which is so much better than having the screen reader read out aloud like 41Z, GD, blah, blah, blah. Like that's what the screen reader usually does with an image without an alt attribute when it has a shitty file name. One more example. This is from another airline site that I looked at. Again, don't do that. Like, it actually uses tables to lay out the label next to an input. That's pretty terrible. But they also have just text and then an input with a name attribute, but nothing else. What you should be using is for attribute on the label and an ID on the input, so that you can actually link the inputs to the label. So when moving focus to this input, the screen reader can actually say departing from edit text instead of just edit text. So if all these seem trivial, they are, but all too often even these aren't implemented, and if basics like this aren't in place, actually spending time with testing screen readers doesn't really make sense, since so many basic things are broke. But once you actually start testing screen readers, you may ask, like, so then have a basic understanding of what a screen reader is. Explained that a little earlier, but where do we start? What screen readers are there? I have two recommendations to start with. One is called NVDA and works pretty well, or runs on Windows and works pretty well with Firefox. You can just go to their site. It's free to use, to download. You can install it, download and install in a minute, and it's actually used by a lot of people who are blind. So that works, and if you're on Windows already, it's basically the starting point. If you're on a Mac, like I am right now with the MacBook, you can go to System Preferences, the Accessibility tab, and then enable VoiceOver. VoiceOver is Apple's screen reader software that comes bundled with the operating system. That also means that it only gets updated when you update the operating system. When preparing this talk, I actually upgraded from Snow Leopard to Mountain Lion, or 10.6 to 10.8, because the VoiceOver version on the older operating system version was really terrible. There are two more to consider. One is JAWS. This is also Windows only, but actually has the biggest market share. Of course, people actually use screen readers. The licenses are pretty expensive, but you can download the demo version, or I think it's called the demo version, that you can run on Windows for 40 minutes before you have to restart your computer. But for actually just testing a few sites now and then, maybe in a VM, where you can just pause the VM, it's still good enough. And it works pretty well with both Internet Explorer and Firefox. usually it's a good idea to just test it with whatever latest version of both Internet Explorer and Firefox there is. The last screen reader on my list of 4 is very different from these 3 because it doesn't actually run on desktop computer, but instead on iOS devices like iPhone and stuff. Since I couldn't record a video of that myself, I want to show you this video of Tommy Edison, the blind film critic, where he explains how iOS uses, how the voiceover, it's also called voiceover, works on iOS.
I just use the voiceover one and it works incredible.
Voiceover on button.
But it's a very cool thing and it allows me to use something that has a touch screen
104.
just like you do.
Slide or double tap.
So each thing,
Double tap to open.
touch it once, it tells you what it is, twice to perform the action.
Notes. Maps. Stocks. YouTube.
And then to move to the different screens, 3 fingers to go left like this.
Page 2 of 4. Game Center.
So let me show you how some of this stuff works.
Twitter. Double tap to open.
So let's. All right, so let's see what's going on in the Twitter universe today.
Chris Moyles. For those watching Love Machine, the girl next to me is actually 8 foot tall, which is why I look short.
Why don't I tweet something?
New tweet button. Text field is editing.
All right, so when I tweet, I generally cheat and use Siri. It's easier that way.
Dictate.
Happy Easter, comma, from the blind film critic.
Happy Easter from the blind film critic.
See, pretty innocuous, nice little tweet. So let's put it up.
Tweet button.
One of the things I don't think people get is when you talk to Siri, if you add the punctuation yourself, it works so well. Period.
For actually testing voiceover, you need an iPhone. It does not run in the simulator, for which you still would need a MacBook. So for my phone examples, I just use voiceover on OS X, since that was somewhat sane to actually make these recordings. And unlike the voiceover on iOS version, the desktop screen readers all have something in common that I label the virtual cursor. They all have different names like virtual buffer, but I just called it virtual cursor. The idea here is that in order to navigate a page and actually read everything that there is, and not just navigate to focusable elements, you can just go to every leaf in the DOM, basically every text node or image or anything that the screen reader can make sense of, can just navigate it step by step through the entire tree. And I want to show you an example of using the virtual cursor. Since this is something where if you've never seen someone using a screen reader, like the keyboard testing thing that works, but that's really inefficient for someone to actually browse a website. So on this demo page, I've put this together specifically to demonstrate screen reader stuff. And in this video, I'm using the virtual cursor to navigate just from one text or image element to the next. And in VoiceOver, to use the virtual cursor, the keyboard command is Control, Option, and cursor right to go to the next element, and cursor left to the previous. Like the combination of Control and Option is used for like most shortcuts in VoiceOver.
HTML content. Heading level 1, earthquake notifier. Heading level 2, we provide email notifications for earthquakes entering main landmark. To use our notification service, heading email. Get earthquake. Heading level 3, privacy. We only use your email address to leaving search landmark entering complementary landmark. Heading level 3, about us. We provide this service for top-down photo of urban destruction image. Earthquake damage on Haiti. Of course we can't.
So as you could hear, when moving the virtual cursor to this image, it actually read out a description of that image. That's what was inside the alt attribute. So that's basically why and how, like why you should use alt attribute and how a screen reader user can actually access that. Because I think with the exception of Internet Explorer, which uses the alt attribute in place of the title attribute to display tooltips, usually the alt attribute isn't really available to the regular browser user. But as I mentioned, this method of navigation is hardly efficient, and of course screen readers provide other options. And instead of walking from just one element to the next and looking for something interesting, screen readers support going directly to specific type of elements. Those include headers, forms, links, basically anything that has somewhat meaning and isn't just some text. There's also support for jumping directly to landmarks, which are a little bit special and not strictly part of HTML. This is the same test page. This time I'm using the VoiceOver feature called Web Item Rotor, which can be activated again with Control and Option and the U. And let's listen to that.
Landmarks, 5 items. Banner, main, complementary, search, content information, headings, 5 items. 1, Earth 2, Weep 3, Subs 3, Private 3, About Us, Form Controls, 4 items, Email required edit, 51,060, Get Earthquake notification, search for Pat.
So since this page has no links, you can still navigate by landmarks, headers, and form controls. Since landmarks aren't part of HTML or HTML5, they might be new to you. But they are really simple to specify. All you do is add a role attribute. The value depends on the purpose of the element. There's roles like banner, which you can use for anything on top of the page. There's main that usually encapsulates the actual content. Complementary is for a sidebar. And content info is usually for some kind of footer. So like this page uses all these. There are a few more, but you probably shouldn't try to use everything. Just keep it somewhat light so that they are actually useful. Now, this page has this form in here, and there's actually some JavaScript attached to that to like use an AJAX submit so that it doesn't reload the page and stuff. And let's see what actually what happens when we submit this form. And something is going wrong here.
Email, required edit text. T-O-N, ton, Y, to, at, G-A-L-M, com. You are currently on a heading level 2 inside of HTML content.
So as you could hear, or notice the lack of hearing anything, it didn't say anything about the loading indicator, and it didn't say anything about the confirmation message that's now displayed here. It didn't say thanks for your submission. Instead, VoiceOver actually ended up reading a heading that we can't even see anymore, since the user, like I didn't do something for a second or two, and VoiceOver decided to just read whatever was somewhat focused the last time. The issue here is something called unexpected screen changes. It basically means that something on the page changed, we use JavaScript for that change, and the screen reader doesn't really know about this change. And it's something that people who use screen readers often have to deal with. Like, it's not as common as like Flash or captures, but it's still pretty high up on the list. And good markup alone doesn't really help here, since the form is marked up properly, but the other two things are just like they're weird, and the screen reader doesn't understand it. So we need a specific solution to fix this. You can fix the issue here by making the overlay and the confirmation elements so-called live regions. For that, we just add the area live attribute, and in this case, I use a value of polite, which is in most cases the right value to use. Basically, tells the screen reader after you're done reading something else, if you're reading something, read out the content of this element. And by default, it reads only the text that actually changes. I'm also using the area atomic attribute here. This tells the screen reader for this element, if the text changes, read out everything. So it should include the header here, this thanks for your submission, but also should read out whatever text gets up and added to the status element. And the JavaScript for this demo, well, at least the fixed one, not the one I showed you, looks a little bit like this. It, in two places, removes classes to make things visible, like the markup was already there, and then just make it visible by removing a class that hides it, and using jQuery's text method to actually update the text content. And after adding these area live and area atomic attributes, this helps with the screen reader to figure out that something changed and it should be announced to the user. Let's check the same example again with those live regions in place.
Email, required edit text. D-A-V-I-D at G-M-A-I-L period C-O-M com. Subscribing, david@gmail.com. 2. Thanks for your submission. We will send you one email to david@gmail.com. Confirm your address. We hope you don't ever get any email from us afterwards.
So now that they're in place, those live regions, VoiceOver announces both changes. And instead of saying something like loading indicator image, which is not really useful, I actually use some text to describe what's happening, the subscribing and the email address. But that's not displayed to the user. Like the user who can see just gets the loading indicator, and the screen reader user gets a text that has some useful information. And then the VoiceOver also reads out the confirmation message. What we've used here and before with the landmarks is our attributes from area, or the accessible rich internet application specification. This is a standard created by the W3C and their web accessibility initiative. I guess they are not that great at naming things, but the work that they're doing here is really important for accessibility. There are two major aspects of area that are really important. One are roles. The landmarks roles we've seen already. There are also several roles for widgets, which we're going to look at soon. And areas specifies various states and properties. We've seen like live and atomic already, and there's a bunch more. Of course, as with any web standard, area isn't without problems, and sometimes making things work requires workarounds. We can't just follow can't just strictly follow the spec. For that, since those workarounds can involve a lot of work to just create them, frameworks like jQuery, on which I'm actually working, so I can tell you a few things about it. jQuery can help a lot, since our goal is to make all the widgets accessible, and that includes testing them with a lot of screen readers. As two examples, I want to show you the menu and autocomplete widget, and again, show you what they look like, a bit of the markup involved to make it work with screen readers, and then show you a demo of what it sounds like with a screen reader. This is a demo I want to show you. It has just those three items and just two menus, so I can actually fit the markup on one slide. And most of the markup is just slightly simplified. As you saw on the screenshots, there's just two top-level items inside a menu, and there's a nested menu with another item. Except for the icon, every of these elements gets a role. There's a menu twice, used for the containers. The submenu also is a role menu, and there's three menu items. There's also role presentation, which I use on these list items because they don't really have any meaning in here, since the nested elements inside the list items are more important. It also has some of these area properties to tell the screen reader about the nested menu. Basically, the state that there is a nested something and if it's expanded or not.
Open menu item, menu 2 items. Open recent menu item. My first document, menu item, menu 1 item, level 2. Open recent menu item, menu 2 items. Open menu item.
So here I use the tab key to just move focus to the menu, and then use the cursor keys to navigate within the menu. So menu manages focus for the user, where you can then use the cursor keys. And you could hear that VoiceOver announces like the number of items within a menu the first time you activate that, and it also tells you that the submenu is on level 2. Let's look at the autocomplete widget as the second example. Autocomplete actually makes use of the menu widget, but since the focus always has to stay in the input so you can continue typing, autocomplete can't actually make use of the menu's accessibility features. Since the autocomplete, the error recommendations for autocomplete actually don't work anywhere, at least not for this type of autocomplete, we had to implement a workaround. The workaround ended up being pretty simple. We're using a live region, which we've seen before, which is the span element here. It has a role of status, which implies area live polite, but that doesn't always work, so we also add the explicit area live attribute. And we use a class called UI hidden, which hides the element from the screen, but doesn't actually hide it from the screen reader, so that the live region changes are still announced. It's not what the specification recommends, but it actually works, so that's what jQuery currently implements.
Tags, edit text. J, 3 results are available, use up and down arrow keys to navigate. J, A, 2 results are available, use up and down. V, Java. S, C, R, I, P, T, JavaScript.
So that works. If there's no results, it would actually say no results available. So I mentioned that both Area and jQuery actually, like Area has issues. jQuery isn't done yet either. Not all of the existing widgets are accessible, and making new widgets that are accessible is still a lot of work. The jQuery Foundation, which sponsors development of jQuery, is also a member of the W3C. So it actually has some influence on these standards as well. So we try to improve Area as well. If you're interested in that, you can actually join the jQuery Foundation, both as individual members with like small yearly fees, as well as corporate members where there's some benefits for the conference sponsorships. Also, as an individual member, you get awesome jackets like these and T-shirts and bags. So if that's something that you yourself or your company would consider, it's a great thing, I think. So to recap, we know that there are people with disabilities who benefit from technology. I presented a few arguments for convincing your boss or clients, co-workers, and so on to actually value web accessibility. We've seen how to test basic keyboard accessibility as well as screen readers, and we've looked at solutions for fixing things just by improving markup or using Area or using libraries like jQuery. And I hope that I could convince you that making websites accessible is worth it, and maybe you can help the next Stephen Hawking. So thanks for your attention, and if we don't have time for questions, just find me later and ask me anything.